For countless generations, humanity has gazed up at the night sky, filled with wonder and curiosity, asking the age-old question, what lies beyond those distant points of light? Our ancestors mapped the stars, told stories about the constellations, and dreamed of worlds far from our own. The night sky has always been a canvas for our imagination, a reminder of how much there is still to discover. Today, with the launch of the James Webb Space Telescope, a marvel of engineering with its golden honeycomb mirrors stationed 1,000,000 miles from Earth, we are finally able to peer deeper into the cosmos than ever before. This extraordinary telescope is not just a tool, it's a symbol of human ingenuity and our relentless pursuit of knowledge. The JWST is more than a telescope, it's a time machine, allowing us to look back billions of years to witness the birth of the very first galaxies. It captures the faint, ancient glow of the universe's earliest moments and lets us probe the mysterious atmospheres of distant exoplanets. Planets that orbit stars far beyond our solar system. Using a technique called transit spectroscopy, JWST analyzes starlight as it passes through the atmospheres of these alien worlds. By breaking down this light, it searches for the chemical fingerprints, unique patterns that could reveal the presence of life or the building blocks necessary for it. For the first time in history, we can study the air of planets that orbit other stars, unlocking secrets that were once thought to be forever out of reach. Central to this quest is the search for water, specifically, liquid water, the essential ingredient for life as we know it. Water is the thread that connects all living things on Earth, and finding it elsewhere could be the key to discovering life beyond our planet. Imagine transforming a distant, unremarkable point of light into a detailed world. A world with oceans, clouds, and perhaps even the conditions necessary for life. Discovering a planet with abundant water would change everything, turning speculation into possibility. Right now, JWST is scanning the skies, focusing on the most promising exoplanets, searching for signs of water vapor in their atmospheres, as well as methane, carbon dioxide, and a host of other molecules that could hint at the potential for habitability or even the presence of life itself. Each new observation is like a clue in a grand cosmic detective story, bringing us closer to answering some of humanity's oldest and most profound questions. We now stand at the threshold of a new era, where the dream of finding another world teeming with life is no longer just science fiction. It feels closer and more real than ever before. The journey of discovery has only just begun. With every new image and every new data point, we take another step into the unknown. The universe is vast, mysterious, and full of secrets waiting to be revealed. Its wonders stretch far beyond what we can currently imagine. And now, for the first time in history, we are truly ready to listen to the signals, the stories, and the possibilities that the cosmos has to offer. The adventure is just beginning. Our journey begins with K218b, a sub-Neptune orbiting a red dwarf 120 light-years away. This Hycean world sits in its star's habitable zone, where liquid water could exist. Hubble first detected water vapor in its atmosphere. JWST confirmed it, along with methane and carbon dioxide. These molecules, deeply linked to life and geology on Earth, suggest a complex chemistry, possibly a vast ocean beneath a hydrogen-rich sky. The absence of ammonia refines our models, hinting at a unique planetary environment. K218b is no longer just a theory, it's a measured potential ocean world. We're now analyzing the air of a possible water planet over 100 light-years away. Among JWST's findings on K218b, one molecule stands out: dimethyl sulfide, or DMS. On Earth, DMS is almost exclusively produced by life, specifically marine plankton. Detecting DMS on an exoplanet would be a game-changer, a strong biosignature, but the signal is faint and unconfirmed. Extraordinary claims require extraordinary evidence. Scientists are cautious, working to rule out errors or unknown chemical processes that could mimic DMS. Even if confirmed, we must ask, could DMS form without life under exotic conditions? New experiments and models are needed to answer that. The search for life is a marathon, not a sprint. DMS is a tantalizing clue, but not yet proof. The journey continues, one molecule at a time. Next, we visit LHS 1140b, a super-Earth just 49 light-years away. It's 1.7 times Earth's diameter, nearly 7 times as massive, and orbits in the habitable zone of a calm red dwarf. Its strong gravity could help it retain a thick atmosphere, crucial for habitability. JWST is now searching for signs of an atmosphere, and especially for water vapor, carbon dioxide, and methane. If found, these would make LHS 1140b a prime candidate for a habitable world. Scientists are also hunting for biosignatures and a nitrogen-rich atmosphere, like Earth's. Every new observation brings us closer to understanding this intriguing neighbor. The search for life is getting personal and local. Now to Toy 1452b, a planet in Draco about 100 light-years away. Its low density suggests it's made up of as much as 30% water compared to Earth's tiny fraction. This could mean a global ocean hundreds of kilometers deep, a true ocean planet. Orbiting a binary star, TOI 1452b sits on the edge of the habitable zone, where liquid water might persist. JWST's mission: confirm its watery nature by detecting massive amounts of water vapor in its atmosphere. If proven, it would be the first direct evidence of a classic water world. Such a discovery would redefine our understanding of planetary diversity. Meet GJ1214b, a fascinating mini-Neptune located about 48 light-years away from Earth. For years, this distant world has been shrouded in mystery, capturing the imagination of astronomers and space enthusiasts alike. Its secrets have remained hidden, making it one of the most intriguing exoplanets ever discovered. The planet's thick, cloudy atmosphere has long frustrated astronomers, acting like a cosmic veil that blocked our view of what lies beneath. For over a decade, scientists struggled to peer through its dense clouds, unable to determine what this world was truly made of. Everything changed when the James Webb Space Telescope turned its powerful gaze toward GJ1214b. Using its advanced instruments, JWST was able to pierce the haze and analyze the planet's atmosphere in unprecedented detail. The telescope detected water vapor, methane, and carbon dioxide, painting a picture of a heavy, steamy atmosphere unlike anything in our solar system. GJ1214b is now believed to be a true water world, but not the kind with cool blue oceans. Instead, it's a scorching, steam-filled planet, where water exists in a superheated, vaporous state. Imagine a world where the surface is hidden beneath thick clouds of steam, and the air is heavy with moisture. Scientists think GJ1214b formed much farther from its star, in a colder region where water could exist as ice. Over time it migrated inward, moving closer to its sun. As it drew nearer, the intense heat vaporized its water, transforming it into a dense, supercritical state, neither liquid nor gas, but something in between. Today, GJ1214b offers us a rare glimpse of a water world dramatically transformed by its proximity to its star. Its journey from a cold, icy planet to a hot, steamy world is a testament to the dynamic processes that shape planets across the galaxy. Thanks to JWST's breakthrough observations, we now know that water-rich planets can be far more diverse than we ever imagined. Some may be covered in oceans, while others, like GJ1214b, are wrapped in thick, steamy atmospheres. Not all water worlds are blue and inviting. Some are shrouded in steam, their surfaces hidden from view, challenging our expectations of what a water planet can look like. The universe's recipe for water is more varied and surprising than we ever imagined, reminding us that the cosmos is full of wonders waiting to be discovered. JWST's discoveries are revolutionary, but they come with limits. We're not seeing oceans or continents, just spectral fingerprints in starlight. These signals reveal atmospheric chemistry, not surface conditions. Water vapor doesn't guarantee oceans. Extreme temperatures or pressures could make life impossible. Biosignatures like DMS are exciting, but must be rigorously confirmed and alternative explanations ruled out. JWST focuses on planets around red dwarfs, which are easier to study but often volatile and hostile to life. Each observation is a clue, not a conclusion. We're mapping a new continent with only a few tools. The search is just beginning, and the universe still holds its secrets close. Finding water is just the first step in the search for life. The next challenge, detecting atmospheric disequilibrium, gases that shouldn't coexist unless life is present. On Earth, oxygen and methane are constantly replenished by living organisms. JWST is searching for these chemical cocktails on distant worlds. The goal: find combinations of gases that defy geological explanation. Future telescopes will go further, mapping surfaces and tracking seasonal changes. Today, this sounds like science fiction. Tomorrow, it will be our reality. The search for water is only the beginning. The search for life is the ultimate goal. The quest for water worlds and alien life is about more than curiosity. It's about understanding our place in the cosmos. For centuries, humans have gazed up at the night sky, wondering if we are truly alone, or if somewhere out there, other forms of life are looking back at us. For all of history, Earth has been our only data point for life. Our planet, a tiny blue dot in the vastness of space, is the only place we know where life has flourished. Every discovery we make about our world shapes our understanding of what might be possible elsewhere. Finding even simple life elsewhere would prove we're not a cosmic fluke. It would mean that life is not a rare accident, but perhaps a common outcome when the right conditions exist. The implications would ripple through science, philosophy, and even our daily lives. It would transform our perspective, making us one voice in a vast, living universe. Suddenly, humanity would be part of a much larger story, one that stretches across light years and eons. JWST's work is a critical chapter in this story. With its powerful instruments, it peers deeper into space and time than ever before, searching for the chemical fingerprints of life. Each planet it studies, K218b, a world with hints of water vapor in its atmosphere, LHS 1140b, a super-Earth in the habitable zone, and TOI 1452b, a promising water-rich candidate, GJ 1214b, shrouded in clouds and possibly oceans, brings us closer to answers. Each discovery adds a new piece to the cosmic puzzle. These worlds remind us that life's ingredients may be common, and that habitability comes in many forms. Some may have vast oceans, others thick atmospheres or icy surfaces, each with its own story to tell. The search continues, driven by our need to explore and understand. Every observation, every mission brings us closer to answering the age-old question, are we alone? Whether we find barren water worlds or thriving biospheres teeming with life, the journey itself enriches us. The act of searching expands our knowledge, fuels our imagination, and connects us to the universe in profound ways. We look to the stars to find others, and to better understand ourselves. Each discovery, big or small, helps us reflect on our own existence and the fragile beauty of our home planet. In this grand odyssey, we are all explorers united by wonder. The search for life beyond Earth is a journey we take together, driven by hope, curiosity, and the timeless desire to know what lies beyond the next horizon.